Alright, so we've got all the vocab we need at this point. We're finally ready to do the determinant of larger matrices. We're going to start with a 3x3 here. Okay, so how are we going to define the determinant of A? Okay, so what we're going to do is we're going to use our cofactors. Okay, so we're going to take the sum of cofactors on a given row or a given column. And we actually get to pick which row or column we use. Okay, so for example, let's say I look at this first row here. Okay, our determinant formula says we're going to take this first entry, okay, A. Now, we're going to also multiply that by the cofactor of that entry. So that's the cofactor at the first row and first column. Okay. And again, we're going to do the sum of each of these. So we've got B, the cofactor at row 1, column 2, and C times the cofactor at row 1, column 3. Okay. So using what we learned in that last video about cofactor, let's go ahead and expand this a little bit. Okay. Well, that is A times, now that's the minor at 1, 1. And then we've got this part here about -1 raised to a power of 1 plus 1. Okay. Let's go ahead and expand these other two the same way. So we have the minor at 1, 2. -1 to the 1 plus 2. And lastly, C minor at 1, 3. -1 to the 1 plus 3. And finally, let's go ahead and just evaluate these powers of -1 here. So that's A. -1 squared is just 1. Okay, so we've just got this. This time we have -1 cubed, so that's going to be minus B minor at 1, 2. And lastly, -1 to the 4th is 1 again. Plus C minor at 1, 3. Okay. Now, this should look really familiar from when we did the cross product in chapter 11. Okay. This is actually that same exact process we did. So in chapter 11, instead of A, B, C, we had those standard unit vectors I, J, K in that top row. And then we put vectors in rows 2 and 3. But we did the exact same process. Okay, we had whatever that top row entry was. Okay, now we have a new term for it. We're calling it this a minor. Okay, but same idea. We're eliminating a row and a column. Okay, and then we also have this alternating sign pattern. And now we know that's coming from this number -1 raised to a certain power based on the row and column we're at. Okay, so let's look at an example now. Okay. So let's say, for example, we've got this matrix 2, 4, 0, 1, 3, 2, okay. -1, -2, 5. Okay. I'm going to call this matrix B, and I want to know what is the determinant of B. Okay. Well, again, we can pick any row or column to do this cofactor expansion. Okay? A general rule is we want to, and I guess I'm going to go ahead and write this down. We want to pick the row or column with the most zeros, okay? Because that's going to simplify life for us. So let's, again, pick row or column with the most 0 entries. Okay. So in this case, we're looking at either row 1 or column 3. Okay. Again, to kind of match the first, what we have up top here, I'm going to do row 1. Okay. So let's go back to red. Okay. So again, we're taking this first entry, 2, times the cofactor at, well, let's write it out this way. The cofactor at 1, 1, plus 4, cofactor at 1, 2, and then we've got this plus 0 cofactor at 1, 3. Okay, but since that's being multiplied by 0, that just goes away. Okay, so let's go ahead and evaluate what we have left. Well, that's 2 times the minor at 1, 1, negative 1, 1 plus 1, plus 4, minor 1, 2, negative 1 to the 1 plus 2 power. Okay. So now we've got 2 times, now this minor at 1, 1, again, we're going to eliminate the first row, eliminate the first column. Okay, so what are we left with? We're left with this little 2 by 2 matrix, 3, 2, negative 2, 5. Then negative 1 squared is just 1. Okay. Plus 4. Okay, what's the minor at 1, 2? See if I can carefully erase these lines. Okay. Now again, this time we're looking at this entry, so we're eliminating the first row and the second column. Okay, so we've got this 2 by 2 matrix, 1, 2, negative 1, 5. And lastly, we use what we know about the determinant of a 2 by 2 matrix. We just evaluate this last bit. So this is 2 times, well, this is again left diagonal minus right diagonal. So 3 times 5 minus negative 2 times 2 plus 4 times 1 times 5 minus negative 1 times 2. Okay. Again, because we're out of space, I'm just going to go ahead and kind of evaluate this all at once. So we've got, in the inside of this first bracket, 15 plus 4 is 19 times 2 is 38. On the inside of the second brackets, we have 5 plus 2 is 7. 4 times 7 is 28, which tells us the determinant of B is 38 plus 28 is 66. Okay, so that would be our determinant of B. Now, we haven't really talked about yet what that number means. We're going to get that in a little bit here. That is a first example of how we calculate a determinant of a larger matrix. Okay. I'm going to do one more video where I'm going to do one more example, and then we'll kind of talk about what this means a little bit, and then I'll get you guys your homework. Okay, so on to video 5.